At this very moment, as you watch this video, a ship larger than 3 football fields slowly glides through the middle of the Egyptian desert. It seems impossible, but it happens hundreds of times a week. That smartphone in your hand, the fuel in your car, the components of your laptop, all probably pass through this narrow strip of water cutting through the sand. The Suez Canal, this blue scar in the yellow desert, is one of the most critical arteries of global trade. About 12% of everything the world buys and sells passes through it. If you have ever tracked the status of a package from China on an app, you are probably tracking something that crossed this canal. When a problem happens in Suez, the entire world feels it. In 2021, the gigantic ship Ever Given ran aground and completely blocked the canal for just 6 days. The result? A congestion of more than 400 ships, empty shelves in European stores, and losses of $9.6 billion for global trade. For each hour of blockage, $400 million evaporated. What few realize is that this waterway would be technically impossible according to the first scientific studies. The initial measurements indicated a difference in level between the connected seas that would make a direct canal unfeasible. What changed this story? Why can giant ships cross the desert in a straight line, while in Panama they need to climb and descend mountains in complex locks? And how does a work completed in 1869 continue to be vital to the world economy more than 150 years later? We will show you the engineering behind this marvel and how it directly influences the price of almost everything you buy. Welcome to the story of how we cut a continent in half to connect the world. The Suez Canal is an engineering masterpiece that transforms the desert into a vital commercial artery. At first glance, it seems simple, a straight line cutting through the desert. But this simplicity hides innovative solutions that face monumental challenges. What makes the Suez so fascinating from an engineering perspective is its scale and the solutions developed to overcome the desert's hostile environment. Unlike Panama, Suez did not need complex locks, as the terrain is predominantly flat. However, excavating 120 miles through sand and rock under the scorching sun was a challenge that required as much ingenuity as any mountain. Seen from above, the Suez Canal looks like a perfect blue line cutting through the yellow desert, creating one of the most impressive visual contrasts made by man on Earth's surface. The layout of the canal was carefully planned to follow a series of natural depressions and lakes, minimizing the amount of excavation needed. The engineers who designed the canal faced an initial challenge that seemed trivial but was fundamentally important, confirming whether there was a difference in level between the Mediterranean Sea and the Red Sea. The first surveys in the 18th century incorrectly suggested a difference of 33 feet, which would have made the project unfeasible without locks. More precise topographic surveys in the 19th century revealed that the difference was minimal, allowing a canal without locks. The original construction used surprisingly rudimentary technology. Without modern mechanical excavators, thousands of workers used shovels and baskets to remove the sand, creating a human chain that passed the material hand to hand out of the canal's path. Eventually, steam dredges were introduced, but much of the initial work was done by arm power. One of the biggest challenges was stabilizing the canal banks. In many areas, the loose desert sand tended to slide back into the newly excavated canal. The engineers developed a stabilization system using rows of palm trees and other plants to fix the sand on the banks. This nature-based solution continues to be used today, with vegetation zones along stretches of the canal. The canal design incorporated natural lakes in its path, including the Bitter Lakes, Lake Timsa, and Lake Manzala. This not only reduced the amount of excavation needed, but also created wider areas where ships could safely cross. These lakes function as natural passing bays, an example of how the engineers worked with geography rather than against it. The original opening of the canal in 1869 was a triumph of civil engineering, but with modest dimensions by today's standards. Only 26 feet deep and 197 to 328 feet wide. With the growth of world trade and the increase in ship size, the canal has undergone several expansions over the years, each representing new engineering challenges. Dredging techniques have evolved dramatically since the original construction. Today, the world's largest cutter suction dredges maintain and expand the canal. These impressive machines can remove up to 4,500 cubic meters of material per hour, using rotating cutting heads to break up the soil before sucking it through giant pipes. A milestone in the canal's modern engineering was the creation of the new Suez Canal, inaugurated in 2015. This ambitious project included the excavation of a 22-mile parallel route and the deepening and widening of 23 miles of the original canal. Most impressive was the timeline. What should have taken 3 years was completed in just one, a feat of logistics and engineering. To execute this project in record time, the Suez Canal Authority mobilized resources on an unprecedented scale. More than 40 dredging and construction companies worked simultaneously, employing 43 giant dredges that operated 24 hours a day. At the height of construction, a fleet of trucks removed 1 million cubic meters of material per day, enough to fill 400 Olympic swimming pools. The dredged material was not simply discarded. In a brilliant example of sustainable engineering, it was used to create new land along the canal, where industrial and logistics parks of the Suez Canal Economic Zone are being developed. In this way, what would be waste was transformed into valuable space for economic development. The canal's monitoring technology is equally impressive. The Maritime Traffic Control Center in Ismailia looks like a NASA control room, with giant screens showing the position of each ship in the canal in real time. Using an advanced automatic identification system, AIS, controllers can track not only the location, but also the speed, course, and type of cargo of each vessel. High-precision radars monitor the canal continuously, functioning even in low visibility conditions. At strategic points, high-definition cameras allow operators to visually observe critical areas. This integrated system allows canal traffic to be managed with precision, maximizing its capacity. The canal's navigation system has its peculiarities. As the canal has no locks, ships navigate in daily convoys, with vessels grouped by size and speed. These convoys are carefully scheduled to cross in wider areas of the canal, such as lakes or in the newly constructed parallel stretch. All ships crossing the canal are required to have specialized Egyptian pilots on board. These highly trained professionals know every meter of the canal and its particular currents. When large ships pass through narrow sections, they can create powerful hydrodynamic effects on the banks. The pilots know exactly how to position the ships to minimize these effects and avoid groundings. Canal maintenance is a continuous and technologically advanced process. Survey barge teams, equipped with multi-beam sonars, constantly map the canal bottom, identifying sedimentation areas. This high-precision mapping creates three-dimensional models of the canal bed, allowing dredging operations to be targeted only where necessary. A constant challenge for the canal is the movement of sediments transported by the Nile and sea currents. To combat this, underwater barriers have been installed at strategic points to divert sediments and reduce the need for constant dredging. These structures, invisible from the surface, represent an ingenious low-tech solution to a persistent problem. The Ever Given incident in 2021, when one of the world's largest container ships ran aground and completely blocked the canal for 6 days, highlighted both the vulnerability and resilience of the canal's engineering. The operation to refloat the ship mobilized 14 tugs, specialized dredges, and an international team of salvage experts. The engineers used a combination of brute force and scientific precision. Dredges worked to remove 30,000 cubic meters of sand and mud around the grounded bow, while tugs pulled the ship with a combined force of more than 400 tons. The operation was synchronized with the spring high tide, when the water level naturally reaches its highest point. This incident led the Canal Authority to accelerate plans to further improve its infrastructure. A project is underway to widen the southern stretch of the canal by another 131 feet and deepen it from 66 to 72 feet. This will allow 2 large ships to safely cross even in this narrower stretch, reducing the chance of another blockage. Modern technology is transforming how the canal handles emergencies. More powerful tugs equipped with azimuth thrusters, which can rotate 360 degrees for precise maneuvers, have been added to the fleet. These tugs can develop up to 100 tons of pulling force, almost double that of older models. Rapid response teams are strategically positioned along the canal, equipped with advanced salvage devices, including floating cranes and high-capacity pumps. Regular exercises simulate different emergency scenarios, from groundings to fires on board, ensuring that the teams are always prepared. A specific challenge of the Suez Canal is the crossing of super-large ships, such as ULCC, ultra-large crude carriers, and EE-class container ships. For these giants, the margin of error is minimal. Sensors installed along the canal constantly monitor the distance between the ship's hull and the canal walls, alerting pilots if this margin becomes dangerous. Despite its apparent simplicity, the Suez Canal incorporates sophisticated technologies that continuously improve its efficiency. One example is the LED lighting system that allows 24-hour operations. More than 3,500 buoys and markers equipped with self-sufficient solar lights precisely delineate the navigable route, even on the darkest nights. Canal security is ensured by advanced systems. Drones regularly patrol the course of the canal, monitoring both maritime traffic and adjacent desert areas. Sensors along the canal detect any unauthorized approach, and thermal cameras allow surveillance even at night. The future of the Suez Canal will bring even more technological innovations. Advanced traffic management systems based on artificial intelligence are being developed that will automatically optimize convoy scheduling, considering factors such as size, speed, and cargo of each ship to maximize flow. Another ambitious project is the creation of a digital canal, a complete virtual twin that will simulate the exact conditions of the canal in real time. This system will allow testing different scenarios and solutions before implementing them, from new dredging techniques to emergency responses. Renewable energy is also transforming the canal. Large solar installations are being built along its banks, taking advantage of the desert's abundant sunlight to power the canal's operations. The goal is to make the canal completely self-sufficient in energy, an example of large-scale sustainable infrastructure. The most revolutionary project under consideration is expanding the canal's width to allow the simultaneous passage of ships in both directions throughout its entire length. This would effectively double its capacity and eliminate the need for scheduled convoys, allowing ships to enter the canal at any time, like a multi-lane maritime highway. The Suez Canal, with its apparent simplicity of design, hides a complexity of engineering solutions and technology that continue to evolve to face new challenges. From the precise dredging of its bed to the satellite monitoring of each ship, this engineering marvel represents the best of human ingenuity applied on a large scale. The next time you receive a product manufactured in Asia or fuel your car with Middle Eastern fuel, remember the impressive blue line cutting through the yellow desert, an artificial artery that keeps the vital blood of global trade flowing. A work that continues to evolve and adapt to connect continents and bring people closer. If you like this video about the technological wonders of the Suez Canal, don't forget to like, subscribe to the channel, and activate the bell to receive notifications. In the comments, tell us what other engineering masterpiece you would like us to address in our next video.